Hello, welcome to FlippedHarber for Algebra 2. In this video we're going to be talking about radical functions. Now our objectives for this video are to learn how to graph radical functions. We're going to take a look at transforming these radical functions, which is a lot like what we've done with other transformations. And then we're going to take a look at graphing radical inequalities. Our outlines for this video: we're going to talk about exponential and radical functions. We're going to take a look at the domain and range of radical functions. Then we'll move on to those transformations of radical functions. And finally, we'll end by looking at some graphs of radical inequalities. Now, the reason we're looking at exponential functions as well as these radical functions is to point out that they are basically inverse functions. So that means that they are symmetric over the line y equals x. Now I want to point out something though here. We see f of x equals x squared. We also see g of x equals the square root of x. Now these are inverse functions. We see a right and a left to the f of x. Why don't we see a top and a bottom? Well, because the square root spits out a positive number. When we take the square root of 16, we generally refer to just the positive 4 there. It only creates half of this curve. Now, a second reason for this, another reason why we only spit out the positive version of the square root is g of x is a function right now. If we included that other half, it would no longer be a function because it would not pass the vertical line test. Now, we can kind of fake it and look at both the top and the bottom by graphing both the positive and the negative square root of x. And now we see both that top and bottom part. That bottom part is obviously caused by the negative square root of x. And now we see the whole thing, the whole inverse of f of x. Now, here we see, even though it's not labeled, we see the different even roots of x. So over here we have the fourth root, actually this is the square root of x, which we've already seen. Then we see the fourth root of x. And then we see the sixth root of x, and they all look very, very, very similar. Okay, all of the even roots, the graphs of those functions, look very, very similar. We see a little bit sharper vertical rise at the beginning, and then it kind of turns and it flattens out again, because it's going to take quite a while for this fourth root of x to rise vertically. Because we're taking the fourth root, it creates smaller and smaller numbers. One thing that all of these graphs have in common, we only draw the top part because we only draw the positive. They all have the starting point 0, 0. We'll talk about that whole starting point when we talk about the domain and range. They all have the point 1, 1 in them, because the square root, the fourth root, the sixth root, the 22nd root of 1 is 1. So we see that in all three of these graphs. Now let's go ahead and move on to our odd roots. So again, I've drawn the function f of x equals x cubed, and I've drawn the g of x equals the cubed root of x. So these are inverse functions. We don't have to do this whole splitting it in half because the cubed root works great with negatives. When we take the cubed root of a negative, it spits out a negative. So we don't have this weird not a function thing if we do it for every number. So works out great. Just the cubed root of x is no problem the cubed root of x. Taking a look at some similar functions, here are the first three odd roots. So we have the cubed root of x, which we've seen already. We have the fifth root of x, looks very, very similar. And we see the seventh root of x. Again, all of these odd roots look very, very similar. We have, slightly different shapes to the curves and stuff. They have a lot of stuff in common, but obviously there's going to be some differences as well. All right, now let's go ahead and talk about the domain and range of these radical functions. And really we can talk about them in big groups. The even roots, square root, fourth root, sixth root, all the way up, all have the same domain and range. We can plug in any non-negative number. Now, another way of saying that is that x has to be greater than or equal to 0. Since we can only plug in positive numbers, we're only going to get out positive numbers. The square root, the fourth root, the sixth root, they will only spit out positive numbers. Excuse me, let me say non-negative numbers. We can get 0 out of that. The square root of 0 is 0. Over in the odd root section, cubed root, fifth root, seventh root, we can plug in any old number we want. We can plug in positive numbers, we can plug in negative numbers, we can plug in 0. So our domain is all real numbers. They will spit out any type of number we want. They will spit out positive numbers. They will spit out negative numbers. They will give us 0. So our range is also all real numbers. Now, we got to talk about transformations of radical functions. Now, really, this is more of the same stuff. We've talked about transformations all over the place. We talked about transformations with linear functions, with quadratic functions, with polynomials. Hey, now it's our time to talk about transformations of radical functions. So, again, all the same stuff applies. A horizontal translation. We add or subtract a number inside the parentheses. In this case, we see that addition or subtraction of a number inside the root. Now, this is all true of whether we're talking about square roots, cubed roots, fourth roots. So I try to throw in here a variety of radical functions. A horizontal stretch or compression. Remember, if we want to stretch it, we divide by the number. If we want to compress it, we multiply by that number. So we see that 1 over in the horizontal stretch or compression. Vertical translations, add or subtract a number at the end, it's going to move it up or down. Vertical stretches and compressions, multiply the whole darn thing by a number, and that's going to give you a vertical stretch. And then we've got reflections, reflecting it over the y-axis. We put that negative inside the square root. Now, that may seem a little bit odd. The square root of negative x, remember, we can plug in different numbers for x. So that is possible. It just means that x itself needs to be 0 or a negative number, and then that's going to exist. So that's why it flips over to the other side. Reflecting it over the x-axis, we put a negative in front of the whole function. That means that we put a negative in front of that radical. So just to go over these specific examples, this plus 2 right here, that's going to move the graph left 2. This 3 right here in the second row, that's going to cause a horizontal stretch by a factor of 3. Add 4 at the end, what's that going to do? That's going to move it up 4 units. Multiplying by a 2 in front, that's going to give us a vertical stretch by a factor of 2. And again, this negative inside is going to give us a reflection over the y-axis. Everything that did exist over on the right side now exists on the left side. And then the negative in front of it all flips it over the x-axis. Okay, now let's take a look at some graphs of some transformations. So I've gone in, and actually these colors are switched, I'm sorry. The red should be the f of x equals the square root of x, and the blue is our g of x, where we multiply by a 3 out front, and we subtract by 2. Now, a lot of times people will ask me, how do I know which one gets done first? Do I stretch it by a factor of 3, or do I lower it 2 first? Well, it's actually a really easy answer to that. We just have to follow the order of operations. So the order of operations says multiply by the 3 first. So that's going to be our first transformation, is that vertical stretch. Then you subtract the 2. So then we shift it down 2. So again, these two colors are switched. The red function should be our f of x. The blue function is our g of x. Okay, so let's talk about the domain and range of some transformed functions for even roots. That's the square root, the fourth root, the sixth root, blah, blah, blah. Only non-negative numbers can be plugged in. Now what that means is when we start out with our parent function, that x has to be greater than or equal to 0. only non-negative numbers can be created. Okay, so our range, y has to be greater than or equal to 0. For even roots, remember that our domain is all real numbers. For our range for, that's supposed to say odd roots. I guess that's what you get when you copy and paste. So for odd roots, the domain is all real numbers. For odd roots, the range is all real numbers. So let's take a look and find the domain and range of this transformed function. The 3 is a vertical stretch. The -2 inside is a shift right 2, and the -4 moves it down 4. Now, we take what's inside that square root. Since we can only take the square root of non-negative numbers, we say that that x minus 2 has to be greater than or equal to 0. Pretty simple to solve that out and find out that our domain is that x has to be greater than or equal to 2. If we plug in anything smaller than 2, we're going to try to take the square root of a negative number. That does not work. Our domain is all x such that x is greater than or equal to 2. Now for our range, remember, our square root has a range of 0 and above. But this one has been moved down 4. So if I get 0 out of this stuff right here, if I actually get 0 out of this, 0 minus 4 is the lowest value that this is going to take. So my range is that y, gosh darn it, y has to be greater than or equal to -4. All right, obviously I got some changes to make to this. Let's go on and talk about the graphs of radical inequalities. Now really, when we want to graph an inequality, we start out by drawing the curve y equals whatever our function is. And then we're going to shade above or below. Whenever y is less than, we shade below. And really the only thing I want to point out here is this nice vertical line to this shade. Do not go beyond the right side of, the left side of this domain. Nice straight shading line down. So y is less than the square root of x minus 3. We draw a great dotted curve for the square root of x minus 3, and then we shade straight below it. When we graph y is greater than, that means that we're going to graph above it. And again, look at this great line right here at the left edge of the inequality. So never go beyond the domain when you're graphing an inequality. That's the big thing. Drawing the curve, no big deal. Deciding to shade above or below it, no big deal. Remember that nice crisp vertical line at the end of the domain. Okay, that's it. So it's time for you to try some of this stuff on your own. I'll see you in class, and I'll see you online.